The question that I have is, could you do a 2D example on finding support reactions by statics? Now we'll try to do some problems where we try to find the support reactions. Finding the support reactions is one of the two ultimate goals for us, right? The second one being finding the internal forces, which we're going to do in the next chapter. So in these examples, we'll do both. We'll develop a free body diagram and then we'll try to find the support reactions. Let's keep reminding ourselves that these are still two-dimensional problems. So here's our first example. We have a horizontal beam AB which is supported at 2 points, at point A and point C. At point A, we have a pin. We have a straight two-force member CD connected through pins at point C and point D is also supporting the beam. The beam is subjected to a vertical point load at point B. The magnitude of the force is 4 kilonewton. The question is to find the support reactions at point A and C. So you want to find the support reactions at point A and C. The only way we can do that is by analyzing this beam. We'll see how it pans out in a second, but that's what we need to do. So the body to be analyzed here is the beam AB. I have drawn the free body diagram right on the problem picture. At point A, we have a pin and therefore there are two forces acting at that point on the beam. A horizontal force AX and a vertical force AY. CD is a two-force member and therefore the force coming from the two-force member to the beam is a force acting like this, right, along the length of the two-force member, and I'm calling that as FC, and this is a rigid member, so this force could be either a compression or a tension. We'll find that out after we solve, but for now I'm marking it in that direction. Now looking at this triangle ACD, I note that this distance is 1.5 meter, this distance is 1.5 meter, right? So therefore this is an equilateral triangle, and therefore this angle has to be equal to 45 degrees because this angle is 90 degrees. So at this point my free body diagram is complete. The force FC is inclined, so I'm going to resolve that into a horizontal and vertical components. My vertical component would be FC sine 45 and the horizontal component would be FC cosine 45. Since this is the direction of FC, these are the directions for the vertical and the horizontal component. In this particular case, resolving this inclined force into vertical and horizontal components like this will help us not only write down the equilibrium equation, the force equilibrium equation, but also write down the moment equilibrium equation on the basis of the principle of moments. As part of that, we first list the unknowns of the problem. So in this problem, the unknowns are AX, AY, and FC, and therefore we have a total of 3 unknowns. To solve this problem, we need 3 equations. Our choices for coming up with the equations are a suitable combination of these equations, a force equation in the x direction, a force equation in the y direction, and a moment equation about a point. So the best strategy is to start with an equation that involves the lowest number of unknowns. If you can think of an equation that involves just one unknown, that's the best because you can go ahead and solve that equation without having to combine that with another equation to solve for unknowns. Doesn't always work out that way, but if you can find one, that's the best. Then you proceed in a similar manner. In other words, your second equation will again be one involving fewer number of unknowns and so on. So these are the bases for developing a plan of attack. So what do you guys think in this problem? Let's brainstorm a little bit. If I sum up the forces in the horizontal direction, AX is going to be in that equation, but FC cosine 45 is also going to be in that equation, nothing else, right? But I'm going to end up having 2 unknowns in that equation, which is in itself is not too bad, but there could be a better way. If I sum up the forces in the vertical direction, AY is going to be in that equation, FC sine 45 is going to be in that equation, 4 kilonewton is going to be in that equation. So I'm going to end up having 2 unknowns again. If I take a moment about point A, AY is not going to show up because AY passes right through that point. AX is not going to show up because that is also passes right through that point, because these two forces are acting right at that point, right? So there's no perpendicular distance to the line of action of these forces. And we also note that FC cosine 45 is also passing through that point, so that's not going to show up. So the only two forces that are going to be on that equation would be FC sine 45 and 4 kilonewton. In other words, we will have an equation that will involve just one unknown, FC. So out of the three choices we just talked about, the last one is the best. So let's start with that. So here's my equation. So I want you to get in the habit of writing this. This symbol contains four pieces of information that are important, that defines exactly what we are doing very, very clearly. Number one, the use of the letter M says it's a moment equation. Number two, use of the summation sign says we are summing up. Number three, this point over here, point A, indicate that we are taking moment about point A. Number four, which is perhaps the most important of all, is that this arrow indicates that the positive direction for the equation is counterclockwise. Because when you sum up several terms, you need to have a basis for the signs, right? So if you don't have the symbol, your equation is poorly defined. When a third person reads your equation, he or she will not understand exactly what you are trying to do. Alright, let's see what we have in the equation. Remember the definition of a moment, right? Moment equals the magnitude of force multiplied by a distance, perpendicular distance to the line of action of the force, right? And we are using the scalar method here. So you could potentially have one term associated with each of the forces acting on the beam. So you want to run through each of the forces acting on the beam and see if any of them will make a contribution to the equation, right? So what are the forces acting on the beam? AX, AY, FC sine 45, FC cosine 45, 4 kilonewton. So there are 5 of them. Now remember, we don't have this FC anymore, right? We replaced this with the two components, FC cosine 45 and FC sine 45. We already talked about AX and AY because they pass through that point, and therefore they will not make a contribution to the moment equation about point A. FC cosine 45 also passes through that point, therefore that will also not show up in the equation. So out of the 5 forces, we have eliminated 3. So here is the term associated with FC sine 45. So the force is FC sine 45, and the perpendicular distance, the line of action, is 1.5 meters. Remember, this is the line of action, right? And this is the perpendicular distance from point A, which is 1.5 meters. And the direction of the moment associated with that force is counterclockwise about point A. So that matches the direction we have chosen for the equation, therefore I have a positive sign in front of that. The line of action of 4 kilonewton is this vertical line, and the perpendicular distance of that is 1.5 plus 1.5, which is 3 meters. And this is giving us a clockwise moment. So I have a negative sign over here. When you have more than one equation, like we will end up having here, it's a good idea to number the equation. So we'll call this as equation number 1. Alright, so I'm going to solve equation number 1. First we simplify it like this, and then we use the calculator to come up with the number for FC. So FC works out to be 11.31. And at this point, you also want to put the units. So all of the forces are going to be in kilonewton. Now I'm going to write down the horizontal force equation. And that equation will have AX in it. The sign of AX is positive because it goes in the direction from left to right. And that's the positive direction for my equation. And the second force that's going to show up in the equation is FC cosine 45, right? Which also has an arrow pointing in the same direction as the arrow in my equation, and therefore that also has a positive sign in front of that. And that's it. Others are basically vertical forces, and therefore they will not show up in this equation. So in this equation, we already know FC, and therefore this equation only has one unknown, which is AX. Now you go ahead and simplify that and find the number. So I get minus 8 kilonewton for AX. Now keep in mind, just as this symbol is important for the moment equation, this symbol right here is important for the force equation. It again has the pertinent information built into it. Now I use the vertical force equation, and in that equation I have AY, which is going vertically up, FC sine 45, which is going vertically up. So these two are going to be positive terms in my equation because I have chosen this vertically upward direction as the positive direction for this force equation. We have 4 kilonewton going down, and therefore that's going to be a minus 4 term in that equation. Set that to 0. Once again, this equation has only one unknown, AY, because we already know FC. So substitute the value for FC in that equation, simplify it, and come up with the number for AY. So I ended up having minus 4 kilonewton for AY. Now we note that we ended up having some positive numbers and some negative numbers for the unknowns, right? And therefore the directions that we assumed initially are not completely correct. Here are the correct directions for the support reactions. We did get a positive sign for FC, and therefore our initial estimate for the direction is correct. So FC is acting in that direction. The magnitude is 11.31 kilonewton. But we got negative sign for both AX and AY. So therefore the directions are reversed from what we assumed. Alright, so 8 kilonewton is acting this way, so that is our AX, and the AY is actually going down. The magnitude is 4 kilonewton. So you can see we don't need to know the directions initially. We assume whatever we think is the most convenient way to do it, and then after you solve the problem, the numbers will tell us whether our initial guess for the directions are correct or not. And that's it. We are done with this problem.